So today we're going to look at utility maximization. We're going to first tackle an example and go over a theoretical explanation as to why that is. So we're given this Cobb-Douglas function, x to the 1/3, y to the 1/3. And we're trying to find out at what quantity of x and what quantity of y is utility maximized. Again, recall that utility maximization is when the indifference curve is tangent to the budget constraint. It's going to be where they're just touching. There we go. So here we have our budget constraint. And here we have our indifference curve. So we want to first find out the marginal rate of substitution. And this is basically how much of one good you're willing to forego in order to consume the other good. So the way we do that is that marginal rate of substitution is also equivalent to the marginal utility of x over the marginal utility of y. So we want to find the partial derivative, which is the marginal utility of x, and then find the partial derivative of marginal utility of y, and then solve or simplify the algebraic equation to get the marginal rate of substitution. So we're going to try and take the partial derivative of x and the partial derivative of y from this function. You have 1/3 x to the power of -2/3, and keep y the same. And do the same thing for y. Keep x the same. And find the partial derivative of y. And simplifying all that, you get your marginal rate of substitution equal to -y over 2x. So now, the point of tangency is the next thing we want to find. And the equation for the point of tangency is the marginal rate of substitution is equal to the relative price of the good. So we have here marginal rate of substitution is equal to price of good x over the price of good y. And up here we're given the price of good x and the price of good y, which we can just substitute into this equation and set them equal to each other. So we have -y over 2x is equal to -2/3. The negatives cancel out. And we end up with y equals 4/3x. So this right here is our point of tangency, which is very important. Or in fact, it is our tangency condition. It's not a point quite yet. So the next step we want to do is we want to sub this tangency condition into our budget constraint formula to get the value of good x and good y. Remember up here we have our budget formula, but we're missing a few variables. Down here we're given the price of good x and price of good y, which we can just sub into the budget constraint formula to eliminate some of the variables. So we have the budget constraint which is the price of x times good x and price of y times good y equal to income. We're given that the price of x is equal to 2. We're given that the price of y is equal to 3, and income is 90. So now we have two equations And we're going to basically sub the tangency condition into our budget constraint to get the value of x. So now we have to sub y equals 4 over 3x into budget constraint. You get 2x plus 3, let me change the color here, 4 over 3x is equal to 90. And then we just solve for x. So we get x is equal to 15. Now we take this condition right here and we sub that back into the tangency condition in order to get the value of y. So you have the tangency condition being y equals 4 over 3x. You sub x is equal to 15. And you get y is equal to 20. So we know that the value of x and the value of y for the utility maximization is x is equal to 15 and y is equal to 20. If you want to double check that to make sure these numbers are correct, we can just resub those into our budget constraint and see if both sides equal each other. Let's do that real quick. So we have our budget constraint formula right here. And we just sub everything in. So we have the price of x, which is 2, value of x, which is 15, price of y, which is 3, value of y, which is 20. And we can see that both sides equal 90. Now suppose we're given this utility maximization equation, where the utility of x and y is equal to the x to 1/4 times y to the power of 3 over 4. But we're not given any other information, such as the price of x, the price of y, or the income. And the idea here is that we want to find out the income, which is the budget constraint, and we want to find out at what point of x and what point of y is utility maximized. So we'll walk through the exact same steps that we've done before, but this time we don't have any numbers to sub in. So the first step that we said is going to be finding the marginal rate of substitution. And we know that's equal to the marginal utility of x over the marginal utility of y. So we have here the partial derivative of x times y to the 3 over 4. And then we do the same thing for y. We find the partial derivative of y. And after simplifying all that, we get negative y over 3x. So there we go. This is our marginal rate of substitution, which is the exact same steps so far as our previous example. Now we're going to follow the exact same steps where we're going to set the marginal rate of substitution equal to the price of x over the price of y, which is the relative price. And that is our tangency condition. But this time, remember, we don't have anything to sub in. So let's do that real quick. So step number 2, let's use the same color. We have to set MRS equal to the relative price. And once we do that, we get negative y over 3x is equal to negative px over px. And after isolating for y, we get net 3 px times x over py. And this becomes our new tangency condition now. So this is our tangency condition. So in the previous example, we had numbers that we subbed in here, which is 2 and 3, and therefore it was easier for us to basically deal with integer numbers. But this time, we're just subbing in the variables, which is the exact same concepts, and we're trying to find out the tangency condition. So the next step we did after that is we had our budget constraint. Our budget constraint was the price of x times good x, price of y times good y is equal to the income. Again, we don't have any numbers to sub in, but what we previously done is that we took the tangency condition right here and we subbed it into our budget constraint in order to find out what good x is going to be, which is the utility maximization function of how much of good x we need to be to reach utility maximization. So let's do that again and sub in this right here into our budget constraint. So we have the price of x times good x, price of y, and then we have y right here is equal to 3 px over py is equal to your total income. And after simplifying all that, we get your income is equal to 4 price of x times good x. And now we want to isolate for x to find out how much of good x we are willing to consume to be satisfied. So then we get x is equal to 1i over 4px. And therefore, this is the formula for how much of good x we're willing to consume to be satisfied. Now, we want to do the same thing for good y. And remember, the way we did that is we subbed in good x into our tangency condition to get y. So let's do that real quick. So y is equal to 3 px times good x over py. Now if we sub in x, which is I over 4x right here over py, we will end up getting y is equal to 3i over 4py. So now we have our two conditions right here. We have that good x and good y. In order to be satisfied, we need to consume this much of good x and this much of good y to reach utility maximization. Now there's another way of doing all of this, which is basically a shortcut to what we did. And it's using the following equations. So we have our utility maximization function right here. And we're saying that to find the quantity of x, we're going to use this formula right here. And to find the quantity of y, we're going to use this formula right here. Now let's take an application example from that. So let's use the exact same equation that we had before to see if we end up getting the same answer. So we had x to the 1 over 4 times y to the 3/4. And that's our utility maximization equation. equation. And as you can see here, let's find x. And we know that the value of a right here is equal to 1 over 4. So, and the value of b is equal to 3 over 4. So let's solve for that real quick. So we have x is equal to a, which is 1 over 4, plus b, which is 3 over 4, over a, which is 1 over 4. And that's our first part of the equation, multiplied by I over px. And we do end up getting the same, I over 4 px. Now if we do the same thing for y, we have again our utility maximization formula equation. We're just flipping around the equation and we're using py instead of px. So we have here the value of a and the value of b. The equation for y is b plus a over b multiplied by the income over the price of y. And as a result, we have 3 over 4 plus 1 over 4 over 3 over 4 multiplied by income over the price of y. And as a result, your y value is 3i over 4 py. And as you can see here, we got the exact same values as we did solving it the long way. And this is the shortcut formula that we can use.